Hello, dear viewers. We're gonna talk about this paper, which are written, I think, by people at OpenAI and are related, according to some sources, to O1 mini and O1 models. The paper talks about taking actions along with language reasoning at this kind of at a sequential manner, and I have highlighted the important parts in here. Well, they try to. Well, let me just go to a simpler form of the model. So basically, you have multiple tokens. You have instruction tokens, you have caption tokens, you have observation, you have taking an action. And well, what the model does is that first the instructions are given to the model. The model is working at an environment 7 by 7 environment like this, in which there's a kind of a cursor thing object, and it moves from cells to another cells. These are encoded in an embedding, in which the last embedding identifies whether there's a door, it's a key, or it's the object is moving. So that's how it's identified. So yeah, so the instructions are given. It says pick up box. Okay, so it has to go pick up the box. So it observes. Okay, an observation is given to autoregressive transformer, and autoregressive transformer says explore. Okay, a caption is given by autoregressive transformer, and note that autoregressive transformer has to give caption or action according to what is given to it, and it has to decide to which one to do in a sequential manner. So it says explore. Explore is given to the autoregressive transformer along with the observation. That is obviously, explore is not given. O1 is given. The observation is given to autoregressive transformer, and autoregressive transformer is deciding to take an action, and the action is taken, and the observation is and then the system observes and gives the observation to autoregressive transformer, takes autoregressive transformer, decides to take another action, and this goes on. And as you can see, here's the caption. The caption goes to the transformer along with the observation. Observation says another caption, and it could decide whether to take an action or take an action or observe. Output caption. So that's the kind of thing that is done. So we have instruction, we have caption, we have observation, and we have action. So the important parts that I highlighted here is, first of all, I'm going to read from it. Our goal is to learn a condition policy pi given action given M, H, and O, and in which given an instruction or mission, which is M, and the history of previous observations. So you need the history of all the previous observations, although in the paper there's a window and not all the observations was given. I assume, I've read it somewhere, so probably that's the way. And last observation is given, so the history is given, and the mission, and the system has to take action. Policy. So that is it. And so the important parts. There's another important part here. I think that this is very important. In our approach, we propose to unify actions and language reasons in a joint sequence. As I mentioned, we train a model that can predict both modalities. We therefore create a new sequence. They create a new sequence because you have a data set that it comprises of actions and captions, and there is a problem of observation, it says in this because you basically have some sort of observation for a caption, and then for action you don't have an observation, or the vice versa. So basically what they do, they duplicate the observations and they create a new data set and train it thereby. So that's how they do it. They use GPT-2 to train the autoregressive model, apparently, and they used sequential. They have reached best results using sequential modeling. Let me see. Sequential encoding, which is kind of a positional encoding. So they say that the performance of positional encoding was not very good, but the best performance achieved by sequence encoding. And this is the result in terms of sequence encoding. Thank you very much for watching. Goodbye.